Hi, this is Jeanine Jue from Samsung ARTIK Cloud, and welcome to our webinar on how to build a smart home with Craft AI and ARTIK Cloud. So in artificial intelligence, there's been a lot of publicity out there in terms of how IoT won't work without artificial intelligence. So think about that. Think about the data that's generated from these IoT devices and services, right? So what can we do with that data and to make your smart home smarter, to make your smart building smarter, to make your smart city smarter? So with Craft AI, the AI as a service allows you to integrate their easy-to-use APIs into your smart home solution, allowing you to create a great experience where any connected thing can automatically learn how to automate itself based on user habits. Samsung ARTIK Cloud is an open data exchange platform for the Internet of Things. You can connect any device, any cloud service to ARTIK Cloud and create these amazing interactions between the devices and cloud services. So we're API first, we're fully integrated. We allow for interoperability in between the devices and cloud services. So if you have a Fitbit device and a Samsung device, they'll work together. It's fully interoperable. And we also have a suite of SDKs to simplify the development experience. Now, our speaker today, Pierre, he's an engineer in cognitive sciences. He's worked in artificial intelligence for over 6 years, and he's worked at Craft AI, leveraging the homemade AI solution to build self-learning systems. Welcome.
Okay. So Craft AI is a machine learning API that we provide developers who have no prior knowledge of machine learning but wants to add a machine learning layer to their applications. So we package our expertise in artificial intelligence into this API so that we can learn about how a single user interacts with an application and provide a personal user experience based on the observed interactions. We have a concept of agent-based model, which means that you will have one agent representing a single user on our Craft AI Cloud. This agent will gather data from this user and generate decisional models that we can use to leverage automation and recommendations. Here are some key points of Craft AI solution. First key point is that it works with a little data, meaning that if the algorithm is able to detect some pattern within a few pieces of data, it can already be used to make some automation. You don't have to wait for a long time so that it can be used. Second key point is that we provide a simple and compact API which allows you to be able to make quickly some proof of concepts and prototypes without having to go deep into configuration like you would normally do with other machine learning solutions. An important feature of Craft AI is that we use a white box approach as opposed to black box algorithms such as neuronal networks. Box approach allows you to inspect and retrace the process leading to a decision. And in fact, for certain use cases, the process might be as important as the decision in itself, and it makes the artificial intelligence accountable. Last key point is that we use a hybrid model, which means that Craft AI doesn't require an uninterrupted access to the cloud. You just need to feed some data at the cloud and retrieve the decision model at some point in time. But once you have retrieved the decisional model, you can use it offline So you don't need to have an internet connection to run the decision of Craft AI. So what can Craft AI be used for? In IoT or smart home automation, smart home application, it can be used for automation, because once we are able to learn in which context a certain device is supposed to be in a certain state, we can just apply it automatically based on a few observations. We can also use Craft AI to make recommendations. For instance, if we are able to detect that a user uses his mobile application in a certain way, given a certain context, wants a certain kind of content, like, I don't know, RSS feed or things like that, certain categories of content, we might be able to provide this content whenever we meet the same context, so that we can make relevant suggestions. And then, since Craft AI is able to detect patterns, to detect the nominal state of things, the habits, we are able also to detect whenever something is out of the nominal case, and then be able to detect that it's an anomaly because it doesn't fit what is the usual situation. So here are a few use cases that we are working on. For connected things, this is what I will be talking about in the example, so I will go over it a little bit later. The second use case, you know that chatbots are really hype right now, but we might be able to give chatbots a little bit more of proactive behavior by recognizing patterns in the way that a user interacts with the chatbot, so that the chatbot can provide content instead of just replying to the user, so being a proactive chatbot. In the matter of personalized coach, what Craft AI can do is provide a program that will adapt to each individual user based on every metrics that are available. Can be scores to some exercises, the frequency and the assiduity of use of the coach application, so that every user will have his own personal coach and not just a static program to follow. Regarding business assistant, just by observing how an expert will process his data in his everyday work, we will be able to make models of business process that will that won't be like experts model with manually input processes. Here it will be able to evolve with time. Every time we are fed with new pieces of data from the observation of how an expert works with his data, we can feed the decision models with this and be able to be more exhaustive on the way it works. And for basically everything that has an interface, Craft AI can allow to make shortcuts in any application just by knowing what the user might want at a certain moment in a certain location. For instance, when somebody is used to check his banking account on Monday mornings when he's at home, we can provide this shortcut to this interface because we are able to know that this is what the user wants in this given context. So you won't need to go through all the usual interfaces. The content will be shown immediately to the user. So now I will present you the CraftAI platform, and you can go and register to CraftAI yourself. It's currently in closed beta, but you can still sign in, and I will present you what it looks like. So when you are logged in CraftAI, you will find this welcome page, which is full of useful links, but the most important parts are to come. So if you go to this sandbox item in the menu, you will have the sandbox is actually an overview of how can CraftAI work, and using a real use case with real data set. You can just walk through CraftAI. This is not the example I will show you now, but you can try it at home just by going to the platform. So this is a useful tool just to experiment with CraftAI a little bit. One of the most important page in the platform is this inspector page, where you will find the list of agents that you will have created, and where you will be able to inspect the decision models for each agent. So here I have an agent that represents what we create with the sandbox application, and you can inspect the decision tree, and you can also browse through time to see what was the state of the decision tree in the past, with a certain amount of context that has been fed to the agent. So this is quite a useful tool that you can use to explain, in fact, the decisions that an agent can take in a given context. Then you will have this settings page, where you will find the authentication token to make API calls to CraftAI. So I will go over the API a little bit. You can find all the details on the documentation on the website, but I will go over a few concepts here. So the workflow to work with CraftAI, as I was telling earlier, it's an agent-based model. So for each element of decision you want to take, you will need to create an agent. So the first step in using CraftAI will be to create an agent. This agent will be configured with what composes the context in which you want to learn. For example, here on the right, you have the context that is composed of two items, presence and light color. It means that we will have an agent that will learn about these two dimensions, these two properties, and we will have the output that we want to learn given the context. And here we want the light color. So it means that this agent it will learn some examples of what is the light color depending on the presence. It will be the number of people, and the output will be the light color. So at a given time, you want to take a decision: what should be the light color given this many people? And this is what the agent will do. It will provide the answer of the color of the light for this many people. This piece, time quantum, this is the significant time resolution for your application in seconds. It means that for this agent, whatever happens within 3 seconds will be considered as a single piece of context. It doesn't see below 3 seconds. So here is quite frequent, but for real life smart home application, you might think of something that along the lines of 30 or 60 seconds, because maybe your devices don't change every 3 seconds. And then the learning period means the period of time that you need to learn habits. And it also means that it's the maximum period of time. So what happens before this learning period is from the past and is not relevant anymore because it's too far in the past. So basically the learning period allows you to just limit in time what you are learning. Then when you have created this agent, you will feed it some context operations. For this example, the context operation will be changes in the light color and the presence, and they will be sent as diff, so you don't need to post the whole context every time, just whatever changes in the context. So if at some point in time you only have the number of people that changes, you don't have to post the light color. You just need to post whatever has changed in the context. Also, if you don't want to take a decision upon these changes in the context immediately, you don't need to post them immediately. You can just store those context operations, and then you will send them whenever you need to take a decision. And we have some SDK that are available that provides all the functions that already do this automatically, so you don't need to bother with this. So once you have provided this agent some context, the agent will be able to learn a decision tree, which is like what you see on the right. And this decision tree can be retrieved through the API, and will be you can download it locally, and then once you have downloaded the decision tree, you can use it locally and offline, and then take a decision for a given context. So here, the last step, taking a decision. When you provide the context for one person, for instance, here, the decision tree will be able to tell you that the light color should be purple, and it has a level of confidence depending on basically the number of times the case has been seen and the number of times other cases have been seen. But you can use this item confidence to filter out some decision if for your application you think this confidence is not relevant enough. So I went over Craft AI. Now I will show you how we integrated with ARTIK Cloud to make an application. So this is the overview of the architecture we have. So we have ARTIK Cloud here in the middle that will be the interface for all the physical devices. It will be able to retrieve the state of all connected devices and push actions to those devices just using the existing ARTIK Cloud rule engine. And then through a custom ARTIK Cloud agent and an ARTIK Cloud application, we will make the connection with Craft AI by retrieving the history of the device's state, send them to Craft AI as context operation, retrieve the decision tree, and use this decision tree to make automation and push actions to the devices, to the physical devices, still using the ARTIK Cloud rules. So our example, it is quite simple, and I've been over it through the example in the API, but what we wanted to do in this application was learning the color of the light depending on the number of people in a room, and be able to automate the change of color whenever the number of people in the room changes. The devices we used were the Netatmo Welcome camera, which has face detection features, so it allowed us to notice whenever somebody entered the scene, the field of view of the camera. And we had a Philips Hue colored light bulb, which could change color through the API. So I will show you a short video of what actually happened with this application. So we learned through some examples, and then we have the camera on the right here detecting that somebody enters the scene, and you can see that the color of the light has changed. On the left of the screen, you can see the ARTIK Cloud dashboard with the changes of the state of the devices. So basically, we just used the application we made to shoot this video, and you can see the automation in the color of the light. So I will go a little bit more in detail into some parts of this architecture. I was telling you that we made a custom ARTIK Cloud device to make the intermediate between ARTIK Cloud and Craft AI. So we had to define a new device type, which is respecting this manifest. We had just a simple manifest for this. So this device type was able to store the current light of the physical device, the current presence count detected by the camera, and also add the information of the predicted light state that was retrieved through Craft AI through the decision trees. And the actions that were used in this manifest were actions that were notifying the device that the color has changed, so that there was a physical change on the Philips Hue, or whenever a person was detected. This is the second action was person detected, so it was triggered whenever there was somebody detected by the camera. I was telling you about using ARTIK Cloud rules. So in fact, here all the interface through the physical with the physical devices is made using ARTIK Cloud. So we didn't make anything on our side to communicate with the devices. We used all the items provided by ARTIK Cloud, and the rules we made to control the light and to retrieve the data from the physical devices and provide this to the custom ARTIK Cloud device or this list. So we have several times the same kind of actions here, which was kind of more convenient for us because we just dealt with a finite list of color instead of the whole color space, just to avoid some problems when there was some approximations in the translation from one color space to another, but well, it's technical detail. So those actions were used when a new predicted light state has been received by our intermediate custom device. We were able to use this rule to trigger the action directly on the Philips Hue physical device. The last two actions, there is this one here, person detected. So it was triggered whenever the camera detected somebody in the scene and triggered the action on the custom device. Here, basically the same thing for light color change. Whenever the light was changed on the Philips Hue, it triggered the action on the custom device, and we were able to retrieve this action. Now I will go over the actual application. This is an overview of how it works, and I will go over the source code to show you a little bit more in detail how it works. But you have three main modules for this application. We have the server module that will be used to authenticate with ARTIK Cloud and retrieve an authentication token that we will use to make API calls and retrieve the states, retrieve the actions that are sent to our custom device and push new states to this device. And this module here will be interfaced with the learning module, which is a helper to make calls to CraftAI through the HTTP API. So it will send the changes in the devices as context operation, and then retrieve decision trees to apply the decision. Using the decision to update the state of the custom ARTIK Cloud device. So you can go on this link, which is a public GitHub repository, so you will be able to browse the code by yourself, but I will go over it a little bit. So I was telling you about the server module. It is just basic OAuth2 authentication. I won't go in detail into it, but it's already working. So if you want to use it as an example, you can use it as it is. We are using the Passport NPM library to make the authentication, and it will retrieve an access token that we will forward to the ARTIK module. Before showing you the ARTIK module, I will go over the learning module, which is where we make the calls to CraftAI. So in this module, we will require the NPM library CraftAI to create what we call a client. So here you will just need to provide the information that you will retrieve from the setting page of your Craft AI account. And this client will be able to, will allow you to make API calls through helpers, through helper functions that I will show you now. So first, the agent, this is the same as the example as I shown you earlier, the same configuration. And we have just a piece of context that we will send at the beginning of the demo to state that the light color will be red whenever there is nobody seen by the camera. And here we can use a confidence threshold, as I told you earlier. We can use this the property confidence of the decision to filter out some decisions whenever it's too low. Here we will keep 0. So at the beginning, we will call the init function with ID of an agent that we will create. And in this init function, first we will destroy any existing agent with the same ID, so that we will start from scratch. So you will just have a new agent with no context afterward. Then we create this agent with the configuration above and the ID we provided. And we will post the context operations, well, the single piece of context operation that we have here to the agent. This is all we do at the beginning. And then we have several functions that we will use in the ARTIK module. The first is update present state, which will allow us to post context operation whenever we have the information that the number of people seen by the camera has changed. We have basically the same for the light color. We have this function update light state to post other context operations based on the changes of the color of the light. And then, more importantly, we have this function take light color decision that we will call whenever we need to make to take a decision and to automate the color of the light. So this will retrieve the current agent context that we didn't store in this application, in fact. And then we will compute the decision for the current context. This will return a decision that we can filter with the confidence. And then we will just return the expected light color for this given context. So now I will show you the ARTIK module. So in this module, we will make the link with the custom ARTIK device. And this is where it starts with this function start that uses the ARTIK token provided by the server module. What we will do is open a new WebSocket, and upon opening, we will need to register our custom ARTIK device so that we can listen to every messages that are sent to it, and so that we are able to push new states to the device. So this function here just uses the WebSocket API. We will authorize the device by sending this message. And when this has been done, we will call the learning module to create the agent. So this is what happens on when we open the WebSocket. Now, what is left to do is to process the messages that are received by the device. We expect to receive some actions that are triggered by the ARTIK rules. So we will see how we do that through this function on message received that is here below. We know that since we define our own manifest, we know that we expect 2 actions, and we will just look at the actions event because the WebSocket API also sends other kind of messages, such as ping messages every single minute, and we don't really need to process them. So we just need to focus on the messages, the action messages, and we will have two action messages, 2 kinds of actions, when the light color has changed and when somebody has been detected. In the first case, we just want to send the new context to our craft agent. So we will update the state of our device, and we will make an update to the agent using the update light state function. But in the case when there is somebody that has been detected, we will obviously update the state of the custom device and update the craft AI agent, but we will also need to take a decision on the light color. And this is what will enable us to make the automation. So once we retrieve the decision for this function, we will update the predicted light state of the custom device, and this will trigger the rule that will actually make the change on the physical device. So basically, this is it. I will show you once more the video, and so that you can see whenever something happens in the application we did. So I will comment. So here the camera will notice that somebody has entered his field of view, field of vision. It will trigger the action person detected, which will be caught by our application. We will update the craft AI agent with this and retrieve the decision for the context presents 1. This new context will update the craft the custom device, and it will trigger in turn the action on the Philips Hue. And then it will do the same with the second person coming in. And we just have a system of buffer to count the number of people in the scene, because the camera tells us whenever somebody is detected, but it doesn't tell us when somebody leaves. So we just have a countdown of a certain amount of seconds, and we consider that the person is not in the scene anymore after a certain number of seconds. So that's it for the code review. If you want any help on how to use Craft AI, you can have those resources available, the documentation with the full API reference, the sandbox, I already told you about it, and we have some startup kits that you can use to play around. And we also have some clients, one in JavaScript and the second one in Python. And we are working on a client in C++ that will be released later on. And if you need support, you can subscribe to the Slack channel of our community, or use the chat embedded in the website, or you can send us a mail at support@craft.ai. Thank you very much, and if you have any question, I'm here to answer them. Thanks.
Thank you so much, Pierre. Do we have any questions? Yes, we did fix the audio, the slides. We are going to be sending the slides out. I'll be sending an email out to all attendees. And what we're going to do is also post this webinar on YouTube in order for you to see. And also, Pierre, do you have a newsletter or something they can subscribe to for any Craft AI events?
I believe there is a newsletter that you can subscribe to on the website, craft.ai. Yes.
Okay. And do you plan on having, and do you plan on having any workshops?
We haven't planned it yet, but we are available to do some if there are some demands. Yes, for sure.
Okay, great. Well, thank you so much, Pierre. We're really excited to see this. And another question too: how long does it take? You know, you built out the smart home with Craft AI ARTIK Cloud. How long does it take to develop that solution? How long did it take?
Sorry, could you repeat the question? I didn't really.
How long did it take you to develop the solution? How long did it take in terms of the code implementation?
Well, quite frankly, demo, we started working before ARTIK Cloud was ARTIK Cloud, because we already started working with the platform when it was still called Sami.io. But we changed the use cases every now and then, and the demo we have here is the demo we had at Slush 2 weeks ago when we were on Samsung's booth, and we did it in probably a week, something like that. But we already had some architecture working.
Okay, great. Oh, we have another question. What is the overall system response time?
Well, depending on the payload of the request, it can vary, of course, but it's within, I think, 300 milliseconds or something like that. Is of course less than a second to have a response for a decision. Well, it can take a long time to send context operations if there are a lot of them, but taking a decision is rather quickly, in fact.
Okay, great.
So making automation is not the problem, really.
Well, thank you so much, Pierre, and thank you everyone for attending. If anyone has any questions or would like additional information, feel free to email us at developer@artik.cloud. Definitely check out our forums and follow us on Twitter. Thanks.